So in this session, we will talk about the future. More precisely, our focus will be on sustainable and innovation in the transport sector. We saw a glimpse of a future yesterday when Starship presented us a self-driving robotic delivery vehicle. Today, a representative of the European Commission will give us a wider perspective on the state of innovation in the transport sector. We will also get an idea of what is happening in the private sector and hear about the new solutions which we will see in the near future and which will definitely change the way we travel. Transport sector is an important factor in tackling climate change, and Alstom offers us a solution for traveling by train without any emissions. At a time when efficiency and sustainability are more important than ever before, Rolls-Royce develops ships that can operate without a crew. In door-to-door traveling time, a trip from Tallinn to Helsinki by plane takes more than 2 hours. As we will hear, Hyperloop One promises to cover the same distance in 6 minutes. The future seems bright. So let me now introduce our speakers for this session. The first speaker is Ms. Maja Bakran-Marcic, the Deputy Director General in the Directorate General for Mobility, Transport Responsibility for coordinating the activities related to investment, innovative and sustainable transport. The second is Mr. Sauli Eloranta, who is in charge of innovation and technology of Rolls-Royce Marine Business. The third speaker is Mr. Nicholas Erb, who is the European Affairs Director in Alstom. And the fourth speaker is Mr. Alan James, who is the Vice President of Worldwide Business Development for Hyperloop One. The debate will be moderated by Ms. Dea Danilov, who is the head of the Foresight Center here in Estonia. And colleagues, as I remind you that you can sign up the debate already now. So now I would like to warmly welcome our first speaker for this session, Ms. Maja Bakran. Dear Maja, the floor is yours.
Thank you, Mr. Chairman, and thank you very much for having invited me to join you here today and to take part in the meeting of the chairpersons of the Economic Affairs Committee on Transport Connections on Europe. Indeed, what I'll try to do, and I believe I have some slides, if we can, yes, thank you. So I'll try to address the subject of innovation in the European transport sector with a first short overview of what the Commission has been and is doing in this area. So first of all, let me just lead you quickly through the current transport policy framework that we have. So a strategy for the long-term substitution of oil in all transport modes was adopted in 2013 and thus giving us a coherent policy framework that guides investments, and of course the target is sustainability and competitiveness of the transport sector, or better yet to say of the overall mobility. We have a directive from 2014 on alternative fuel infrastructure, and it is exactly this directive that is becoming very important today. It was a political signal, it gave us a regulatory framework, and the Member States had a deadline of November 2016 for transposition and equally important for notification of their national policy frameworks. Now, I have to say we haven't yet, even though the deadline expired almost a year ago, we haven't yet received all the policy frameworks. We have received 23 out of 28, so we are, if I may say so, chasing some of the remaining member states to submit their frameworks. Why are they important? because what is going on is analysis within the Commission of the received frameworks, and will come up with the action plan containing basically recommendations to the Member States how to speed up this rollout of alternative fuel infrastructure, and we'll come up with this action plan in November, at the beginning of November, so in about a month and a half time, and it will be part of the second mobility package. At the same time, we'll also come up with additional financing from EU budget for, again, the rollout of alternative fuel infrastructure. Thirdly, we have low-emission mobility strategy adopted in November 2016, and again, there is a strong emphasis there on the role of the alternative fuel infrastructure. Quickly, important milestones happening this year. A few months ago, end of May, we published the Europe on the Move, or as we call it, the first mobility package of the year. It's a wide-ranging set of initiatives that will make traffic safer, encourage smart road charging, reduce CO2 emissions, air pollution and congestion, and also cut red tape for businesses, fight illicit employment and ensure proper conditions and rest times for workers. Included in this package was the staff working document on STRIA. It is quite a bureaucratic name. What's behind it? It's strategy for research and innovation in transport for the years to come. Now, as I already mentioned, the second mobility package is coming up beginning of November. And I should move to the next slide. And in it, we'll have a set of 8 legislative initiatives on road transport, all of them closely related to our today's subject, the future of transport. So we'll deal with emission standards, revision of Clean Vehicles Directive. We'll, as I mentioned, assess national frameworks on alternative fuel infrastructure, and crucially adopt this action plan on alternative fuels infrastructure. We hope to help or to give an additional impetus to further drive innovation, to improve competitiveness, to reduce CO2 emissions. Transport is almost 1/3 of our CO2 emissions, and unfortunately, as opposed to other areas, emissions in transport are not even stagnating or falling, they're actually slightly growing still year on year. We hope to thus improve air quality and public health and increase safety, which is also an important element. Next spring, we'll come with the third mobility package, and in it we'll truly focus on innovation. Now, maybe just to go quickly through the new strategic transport research and innovation agenda, the STRIA, as we call it, abbreviated. So various priority areas have been identified in the document through expert discussions and wide-ranging public consultation. We hope to really enshrine this integrated approach and multimodal perspectives. We, of course, it's mobility as a service. We'll focus on human-centered transport solutions. What the actions contained in the document are short-term and long-term, and this is important. So in this strategy, we are actually trying to stay flexible enough and to react to the long-term demands. So the time horizon is 2030, even 2050 for the actions proposed. You're probably all aware of the important research and innovation instrument, European one, Horizon 2020, which dedicates a large, significant part of its funding to transport. And of course, the key word here is towards clean, competitive, and connected mobility. You see on the slide the 7 priority areas, and as you can see, transport is changing dramatically. When you see priority areas like cooperative, connected and automated, electrification, smart mobility and services, these are indeed the priority areas that we did not really have before, but we have to adapt to the fast-changing world of transport or mobility in general. Now let me move from Horizon, which is our research and innovation instrument, to Connecting Europe facility, so concrete infrastructure financing Europe-wide instrument combining three crucial sectors: energy, digital, and transport. I'll focus here on transport, of course, and you can see an overview of the calls we had in recent months. We had a novelty, we had a synergy call, so projects combining the two sectors, energy and transport, were eligible in the amount of 40 million, so this was the first one. We are satisfied with the interest shown, with the projects that applied, and certainly we are working with colleagues in other directorates general of the Commission, notably DG Connect and DG Energy, to come up with new synergy calls, probably combining all three areas. Coming back to the more classical one sector call, transport call of October 2016, where we had about 2 billion euros for all priorities. This call is also closed, and we are happy to have received 54 eligible proposals in innovation. Now, what's crucial, of course, this is grants only segment of the call, and as usual, also there's a special envelope for cohesion countries. So you have some additional information in the slide. Now, within CEF calls, we have introduced also the innovation priority, and we had another novel instrument, the so-called blending call, this February. So the project promoters receive an amount of grants, but they also, in order to fully finance the project, they also need to talk to European Investment Bank, national promotional banks, and so to say, create a whole envelope, financial envelope to finance their project. So, in short, it's blending, means grants and loans in one proposal. We are proud within DG Move to have been the first within the Commission to launch this new financial instrument, and indeed, in the current budgetary environment, innovative financial instruments are here to stay and to further enlarge. We are also very happy and satisfied with the results so far. The call is still ongoing. The first deadline passed before summer, and we already have an oversubscription of projects. Of course, currently we are analyzing and estimating various projects that applied. What is crucial to now also understand, it's really happening. The page is turning, as you can see in the slide. We are going to finance about 1,200 refueling stations and through these innovative funding instruments. European producers understand the urgency to mass produce the vehicles. We really have to speed up our actions, and along the 10T corridor network, which is our basic framework, really to roll out the alternative fuel infrastructure. On this map of our 10T corridors, you can see various projects related to the deployment of alternative fuels, and of course, only a few years ago, you wouldn't have seen Europe as dotted as it is. However, when you look closer, you still, of course, see areas where there's gaps and where we need to find incentives to really roll out various alternative fuels. In the final part of my intervention, I would like to also share with you some very concrete examples of different projects, and I've also tried to spread them, so to say, over different alternative fuels. Here you see a real-life trial that is taking place and is intended to pave the way for a large-scale rollout of LNG fueling stations for truck transport along the TEN-T core network corridors. And we have 9 member states taking part in this project. The total project cost is 55.5 million euros, and EU contribution, so EU budget contribution, is almost 28 million. Now let's move on to electricity. Again, we have a real-life trial study with integrated pilot development of 241 multi-standard fast chargers in Germany and 37 in Belgium, and this is complemented by additional 29 in Slovakia and the Czech Republic. The entire network is operated through an open-source ICT platform, allowing for roaming facilities and market development at EU level. Moving on to third type of alternative fuel, hydrogen. Again, another project that is a real-life trial and looks into sustainable hydrogen production pathways. This is taking place in Holland and then, of course, in Estonia and Latvia. And finally, to switch to other modes, maritime, again, a local example. Twin Port 2 is the name of the project, and it's a study plus works aiming at upgrading the maritime link between the port of Tallinn and the port of Helsinki, which I understand some of you present here today actually will be traveling on this line later today. Why is it so important to also be fully aware of these good examples? All of these projects can actually serve as flagships, can actually share their experiences and help project promoters, people who prepare projects in other member states, to really learn from their experience, to become more and more active, and to put forward new projects. On this slide, you still see some additional milestone projects, and of course, behind these projects, there are milestone people without whom we would not be in a position to actually truly start making a difference and start changing the way we approach and the way we travel. I'll finish with one key message, and that is we must further accelerate. All of this that I've been talking about is a nice start with infrastructure. Industry is shifting up a gear. We'll hear something more from my fellow panelists, but we need to further accelerate. We need to look into synergies between sectors, modes, etc., and do really this user-friendly roaming or blending, as however we want to call it, that works. We have to really ensure sustainable transport. We have to achieve our climate goals, and we have to change the way we approach mobility, really make it consumer-centered, and truly enjoy in mobility as a service, which I think all of our citizens, and especially the younger generations, demand from us. Thank you.
Thank you. Thank you, Ms. Pakran. Very interesting overview. Now I'm delighted to give the floor to Mr. Sauli Eloranta. Please, Sauli, could you give us an overview what Rolls-Royce will do with new technology? Please, take the floor.
Thank you, Mr. Chairman. Ladies and gentlemen, thank you for the opportunity to talk about autonomous ships here today. I will start from slightly further away to give an introduction. What is autonomy about? Why do we do this? And so on. So you can recognize, hopefully, a lot of the logos, commercial logos, what are there on top of this slide, which are disruptive business propositions, platform-based approaches, blockchains, all kinds of things that are quite new at the moment. So they are kind of let's say, an alternative to normal pipeline-type business approaches that we are also used to and which we feel very comfortable with. Now, what is remarkable is that those disruptive business models are slowly making their way also to maritime business. I think the fact that there is a limited number of ships, around 100,000 ships in the world, is also kind of protecting the maritime business, that it's not in the immediate interest of big, let's say, global companies like Amazon to attack maritime business first. That's not good, because the more threat there is, the more we need also to harmonize and digitalize our own business. Now, from these blue boxes, you can see that there are some ship owners that I could call enlightened. For example, you can see Maersk, the Danish ship owner, mentioned several times, and they are investing in blockchain technologies and platform technologies. They are connecting with IBM Watson and Alibaba and what have you. So this is just a slide to show that the maritime business is slowly also getting digitalized. And it's not only, I mean, I'm an industry representative, so it's not just, let's say, the measures and means of let's say, governmental support, but these are purely business-driven initiatives to turn the industry. So we believe that there are tremendous saving opportunities in our business, maritime business and logistics, when it comes to building it more digitally streamlined compared to what it is today. It's very, let's say, transactional, and there are lots of interfaces. So also to correct maybe a misperception of autonomy, we're not aiming at building expensive, exclusive, technically challenging vessels, but instead, this will be a low-cost alternative to shipping. So a manned vessel actually is more expensive to build, these crew quarters and all the supporting functions, making drinking water for the crew, having cabins, having life-saving equipment, all of those issues, they cost. They make the vessel larger and so on. So the intention with ship intelligence, autonomy, remote control is to introduce a new wave of lower cost shipping. So therefore it is actually a disruption. It is a major cost benefit for such operations. It can also allow for new types of services, like we know from self-driving cars. Once you go towards that direction, it opens up a Pandora's box of new operating models. And for us, for example, it can be much more direct routes, point-to-point routes, which are uneconomical to do today. So today the term is consolidation, physical consolidation. And then in the future, it might be possible to let's say, get the same cost savings as a consolidated service through these technical improvements. Now, autonomy is attacking cost issues of shipping. It attacks environmental impact, and it also impacts safety issues. So if you take a look at the cost pie, you can see that's quite a lot of capex. So capex can get reduced when you build a less expensive ship where crew quarters are not there. That would be maybe 10 million euros per vessel or so. The manning cost would disappear more or less, so that's 17% cost share, and then there would be some savings also in fuel costs. So there will be several cost elements that are impacted by autonomy. And then, of course, not to mention operational, let's say, issues like how you operate with these things, so that is also providing more savings than these direct ship savings. Fuel savings are making it possible to have more sustainable transport because the vessel displacement or the size of the vessel is slightly smaller because it's not manned. For safety, I think the first perception for us is that safety is worse, when machines take over. But I think if we heard this morning about this road safety, it is 90% roughly that humans cover for marine accidents. And it's not, let's say, an intentional mistake. It's more about fatigue. It's dull, to operate a vessel throughout Indian Ocean where you don't see many things, in many days. So it's normally fatigue. People get tired about, observing their environment, whereas an autonomous ship has equipment like situational awareness and sensors that are taking care of observing the surroundings of the vessel. Now, what will happen next is that we have different roadmaps. This is one that we operate at the moment. So 2025 would be the timeline for remote controlled and autonomous ships, more or less on a national level without restrictions. So that is important to know. That is what we are aiming at. And we have already done remote control, and we have one remote controlled tug, for example, in the port of Copenhagen that is operated by Danish company Svitzer, that is already in operation, but it still has a crew on board, so it's not yet certified to operate without a crew. Now, what we do as a company with this theme, for example, some news about this year, our company announced an investment of £200 million, so that is a nice, let's say, offer from Rolls-Royce Corporation to make an investment in remote controlled and autonomous shipping. At the same time, we also announced to set up a new R&D center in Finland for remote control and autonomous ships. And I think that the membership of Finland, being a part of European Union, also played a role in that decision. And of course, the national innovation system and framework in Finland. But being a part of Europe seems to play to our advantage. Second one is a commercial application of situational awareness systems with the Swedish ship operator Stena Line. And the third one is the one that I mentioned, the remote operated tug in the port of Copenhagen that we have done. So these are kind of things that we have publicly announced that we have done this year. So it's quite a lot of steps, quite a lot of advancements we can do in 1 year. This is quite interesting that competitors, like we have here, ABB, Ericsson, Wärtsilä, we have our competitors and we have joined up in the same ecosystem. So the intention is to create industry standards to support the introduction of more automatic solutions in maritime traffic. We opened up a test area in Finland about a month ago. And we also brought this topic to the International Maritime Organization, and to a great surprise for all the 172 nations were backing up a decision to take autonomous ships to the agenda of the International Maritime Organization. So this is probably going faster than most of the experienced professionals in our industry were feeling. I think it was because there started to be quite a lot of commercial demonstrators out there. So now, pretty much my plea to all of us as European citizens is that we need to identify how fast the technology development is. We normally take a look at our own, let's say, field, but what is important is that we must take a look outside of our own field, outside of our own industry or our own, let's say, subject matter area. So this digitalization needs to be understood quite holistically. It will change business models. So technical changes are not the ones that are important, but the ones what the technical changes will enable are important. So it means a radical change in business models, and also an opportunity or a threat for a lot of European business to end up in the hands of global players. Like all of our daily grocery shopping can end up in companies like Amazon. I mean, it's just a very, let's say, plausible, let's say, alternative for us if we are not playing our cards right. Then I would call for joint strategic approach aiming at global leadership. So nothing less than global leadership. And in some areas we do have a point. We have a strong automotive industry in Europe, strong aerospace industry, strong marine industry, strong ICT industry. I would just combine and bundle those more together to create a multimodal approach. And for example, in a theme like autonomy, autonomous vehicles, I would like to bundle those more together so that we get rid of a modal-specific approach into something what is more strategic. There are some topics, data, comms, cybersecurity. There are lots of technical issues that have to be tackled. we feel it needs to be industry-driven. And industry is not always mature to take the leadership in here. I think that when we have taken steps towards automating the maritime business, that we have underway, we have understood how we need to responsibly take initiative in taking it forward. Then what was mentioned this morning is the ethical agreements with citizens. You know, what does this autonomy, automatic mean for all of us? It needs to be, we need to give real information to people, and we need to allow a public debate around the issue. We need to understand that there are also personal fears of people about, you know, losing jobs and what have you. We need to tell about the time frame. We need to tell about how we are improving the training and education in Europe. And then we need to prepare for post-manned operations, you know, because that will come. You know, when it will come, it's slightly more ambiguous, but we'll need to prepare for that in a social setting and educational setting. Power of a vision. So this is something that we have a YouTube vision published, so I hope that these slides will be made available to you. That was quite interesting that we have got hundreds of thousands of viewers for a vision which is not typical in a shipping industry, because it is quite a conservative industry. Maybe most industries are. But this is something what is triggering the interest also of the younger generation to join the journey, so that we have had no issues of recruiting people to join us. And this is my final slide. What we are doing is nothing less than redefining what shipping is. So the one on the left bottom is our most up-to-date commercial solution, so-called unified bridge. Next one is a vision of how it could be, and the third one is actually this Switzer remote operating center. So we came from today through our vision to where we are, you know, our tomorrow's propositions, which are demonstrated already today. Thank you.
Thank you. Thank you. Thank you, Mr. Elorant. It's always interesting to look future and listen private sector how they will manage their money and what's our thoughts how to be more effective. So next representative of private sector coming from Alstom. I'm delighted to give the floor to Mr. Nicholas Erb. Please, dear Nicholas, the floor is yours.
Thank you very much. So it's an honor to have to be able to address you today and present the technical solution we are developing to enable a complete emission-free railway system. Well, very quickly, for those of you who do not know Alstom, if you are not familiar with, let's say, the railway industry, we are a group with a turnover of about 7 billion euro, 30,000 employees, and we develop trains, signaling systems, infrastructure, and maintenance. So all the range of products which is used in the railway environment, from metros to very high-speed trains. Now, some of you may be wondering, but actually railways are, or think that railways are entirely electrified already. It's not quite the case. It's true that you cannot call electricity really an alternative fuel in rail, because that's really mainstream for us. Most of the rail network in Europe, or the rail traffic in Europe, works on electricity, because it enables us to have trains that are heavier and can run faster. You would not have very high speed on diesel, clearly. However, electrification has a cost. I mean, you have to install the catenaries, the substations, and so it's quite capex intensive. And even today, about 40% of the European railway network is not electrified. So that covers especially regional and low-density lines, and as well, let's say, last mile, so freight terminals and shunting yards. So all that is still a significant number of kilometers of lines. And the difficulty is that since locomotives, or let's say trains, are in service for about 30, 40 years, the renewal rate is quite low, meaning that let's say it's extremely difficult from an economical standpoint to introduce better, let's say, the latest generation of diesel engines in railways, because the quantities are so small that when you spread the investment cost over 100 engines per year, it's extremely difficult to make that happen for the suppliers. So we've had this problem facing the European railway industry, and we still have it. And what we've tried to do as Alstom, and I think it was also mentioned by the Commissioner and Mrs. Dele this morning, that we really have to try and decarbonize all the European transport system if we are to meet both the climate challenge plus as well improve the air quality in our cities. So we have to find a way to substitute diesel in railways. So the mission that we have set ourselves is to define a system solution that would enable to replace gradually diesel trains and diesel locomotives by fuel cells. It has to be, let's say, a system approach, meaning that since you change the fuel, you not only have to look at the vehicles, but you also have to look at the fueling infrastructure, where the hydrogen is coming from, storing the hydrogen, etc., etc. So it's you really have to look at to provide a complete package, so that operators can manage the operation. They come in the morning to take the trains and put them into service, and they have no problem. Let's say for them it's a transparent thing whether it's a diesel train or a hydrogen train. So we've presented actually our first prototype of a fuel cell train 1 year ago in Berlin in a big trade fair which is called InnoTrans. It was quite successful actually. In terms of, let's say, media attention in the railway trade press, we got a very good result. So very happy with that, obviously. And we also, perhaps to explain, it's actually an existing design of a diesel train that we have adapted for fuel cell, which also helped us to go a bit faster in the development. But at the moment, let's say as a supplier, we've actually built 2 prototypes. They are right now undergoing homologation in Germany. So in the railway environment, that can be a long process. It usually takes about a year to get, let's say, a real authorization to drive in commercial service. So because we started from an existing design, we hope to get that authorization, let's say, very end of this year, so that we can start using this prototype in test operation next year throughout Europe. So in theory, if we win one of a tender with these trains, you would have a first fleet of fuel cell trains operating in Europe in 2020, 2021. That is the target we have set ourselves. So obviously, from let's say what you would call a tank-to-wheel perspective, with fuel cell, you have zero-emission railway vehicles. And even if you take a step back and you look at, let's say, a well-to-wheel perspective, you have a significant improvement compared to diesel trains with what we call, let's say, gray hydrogen, so hydrogen coming from natural gas reforming. And if you are able to use hydrogen coming from renewable electricity, then, of course, you go to a complete, let's say, a zero-emission train system. So in terms of numbers, it may, at first we talk about fleets, about 10, 15 trains here and there, so it may not seem like a large number. But when you compare it with the automotive, what you have also to keep in mind is that each train would have, well, this one, for example, so the one we have showed last year, has about 300 kilos of hydrogen on board and has to be refueled daily. So in terms of quantities of hydrogen that you need for a fleet, you reach actually quite significant numbers, which is interesting because it can create a whole, let's say, it can contribute to a whole hydrogen economy, which is a concept that we see emerging, especially in the Netherlands and northern Germany. And also the fact that these are usually public transport concession or public service obligation contract means that the deployment of infrastructure and the vehicles can be coordinated by the public transport authority. So you don't have a risk of stranded investment, of having invested in infrastructure without having any vehicles or vice versa. Here you can have this perspective of dealing both at the same time with the infrastructure and the vehicles. It's obviously very attractive for some other countries, and here you can see the map of Germany in particular, which have some significant renewable energy production capacity, because from time to time they have an excessive energy production and they don't necessarily have the demand right at the same time. So the concept is, of course, that you would use this electricity to produce hydrogen through electrolysis, and you would then fuel or channel the hydrogen to your fueling station for trains. And why not? You can imagine as well having a fueling stations for cars next to it, because in terms of quantities, it becomes very manageable. Now the picture is not perfect because, well, let's say national legal framework are quite different, especially on energy taxation. So even in Germany, for example, what we see is that the competitiveness of a package is hindered at the moment by the fact that there are some quite heavy taxes on hydrogen coming from renewable electricity, which for us is a pity because it's more taxed than diesel. So it comes, let's say, it hinders the competitiveness of a zero-emission solution compared to a traditional solution, which is well, not very coherent, let's say, from a climate standpoint. So to conclude with some points on what, let's say, the barriers that we are tackling at the moment to deploy this technology, and the way Europe is helping already or could help even more. So as I mentioned, as in over, let's say, alternative fuels debate, the issue is that customers have to deal with the extra cost of especially infrastructure cost. So to invest in a different fueling infrastructure. And that's especially, let's say, that takes time as well to manage, because that means that in the transport system you need to have an alignment of priorities between the public transport authority, which can be regional or national, the infrastructure manager who owns the infrastructure and who would have to host this infrastructure, this fueling infrastructure, and the railway undertaking that then has to operate the corresponding vehicles. So you need to find an alignment between different stakeholders. And you also need, when you are in an environment with, let's say, with competition between operators, you also need to align that with the duration of public service contracts. So it's, let's say, it takes a little bit of time to mobilize and to make sure that all the stakeholders have the same view and the same priorities. We also have an issue because I think my colleague mentioned previously that industry is sometimes conservative. In the public transport, a lot of authorities are especially conservative and, let's say, dislike technology risks, because if your train doesn't start in the morning, usually you have a lot of media attention around it and a lot of questions to answer. So the fact is that this type of, when you come with a really disruptive technology like this, it's easier to make a first deployment or large-scale, let's say, deployment on secondary networks, because it's, let's say, less critical parts of your infrastructure. And yeah, we'll come, that's actually a little bit an issue, for example, when you talk about connecting your facility, which is where a lot of the funding is focused on the core network corridors. And taxation on hydrogen, this I will not come back to it. So I think we have in Europe a very strong base or very strong industrial know-how in public transport and Norway in particular. I mean, that type of solution or development, among others, can be a real contributor to maintain this competitiveness and contribute to the jobs and growth agenda of Europe, while at the same time contributing to the decarbonization of transport and make railway, as I mentioned, a completely emission-free transport system. What we would see as perhaps food for thought for debate as to how deploying such technologies could be easier would be, on the one hand, a real valuation of a reduction of the emission of the CO2 emissions, because today, in a normal public procurement process, that doesn't help you. If you come with a product which emits less CO2, well, good for you, but it doesn't change the, let's say, the evaluation of a tender. So, for example, well, there's a Clean Vehicles Directive for road vehicles purchased by public transport authorities. One could think of a version for trains. And in addition, I think we really support the work that has been done by the Commission, both in Connecting Europe Facility and as well with the joint undertakings, the relevant ones being here fuel cell and shift to rail. And I think it's really worth continuing to actually support these developments for the European industry. We look forward as well for the fuel cell undertaking to spend a bit more attention to the rail transport. So far it has been focused a lot on automotives. We also need to look at, let's say, the last step of technological validation. So how to support the first, let's say, real-life commercial project to really create a confidence from the market in the solution. And later on, but that's going into a bit more details, which is, okay, we have started with regional trains. There's probably some potential to look at fuel cell for all the types of railway applications, or last mile application of freight transport. But that will require, let's say, further investigation, because the mission profiles are much more different. The autonomy requested is much longer, so that will come at a later stage, I think. Okay, thank you very much.
Thank you, Mr. Now we got an overview from two private sector representatives, and the third one, Alan James, coming from Hyperloop. Please give us an overview. What's going on? You said yesterday that it takes only 6 minutes from Tallinn to Helsinki.
Yeah.
Please.
Mr. Chairman, distinguished parliamentarians, it's my honour and pleasure to be with you here today. Maya, in her remarks, said we need to accelerate further. Well, I've got good news. We can do that. And I'd like to take you through some of the accelerations that we're going to bring to transport. So, I have the great good fortune to be in charge of global business development for Hyperloop One. And I'd have to report there is strong interest from all around planet Earth in transformational transport. The downside is I live about 30% of my life on aeroplanes, which I don't recommend. So we want to change that. And I specifically today want to address the opportunities that we think exist in our universe, the Hyperloop One universe, for Europe, for the European Union. And I apologize, of course, for the inevitable irony of being a Brit, extending that view. So if you don't take a helicopter shot, but you take a space station shot of Europe, you can see that you've got to get transport infrastructure right, because it lasts a very long time. So if you look at this map, you can see the furnace of the Industrial Revolution in northern England still burning bright, 200 years after Stevenson. You can see the great corridor of the Rhine still illuminated. And you can see the big natural obstacles, like civilization pushing up Italy until it reaches the barrier of the Alps. So we're at a moment in technical development where we're developing an entirely new transport infrastructure. But it's not done in isolation. Transport happens in an environment where other transport exists, and we know we have to interface with it. So what are the opportunities for Europe? I'll come on to that. But to understand that, let me first take you into what Hyperloop One is and what our technology is. So I think everybody in the room knows that the original concept for Hyperloop was proposed by Elon Musk in 2013. Before August 2013, nobody had ever heard of Hyperloop. The concept didn't exist. And he basically said, you take a vehicle, you put it in a tube, you take the air out of the tube, and it goes really, really fast. And then he said, I'm too busy with Tesla and with SpaceX, and I want to colonize Mars, so I haven't got the time, so just get the brains together and go build it. So a lot of people took that statement from Elon to mean go and make PowerPoint presentations. We took the boring, old, traditional approach of actually going out, raising hundreds of millions of dollars, and getting 300 of the world's best engineers and associated professionals into one place, and we've built it. So that's the big news. So I want to stress that what you see now is not a Photoshop. It's actual photos from our actual test and development site in the Nevada desert. Our Chief Technology Officer, Josh Geigel, who's a man who's built rockets, he refers to this as our tube farm. This is where we plant them and they grow. He's joking, of course. What we've done is test them. This is in particular a test of thermal expansion. It's freezing cold at night in the desert and boiling hot in the day, so we needed to test that. We've built the infrastructure, we've put it into place, it exists, and that's what we've got now. This is our DevLoop site in the Nevada desert. I don't want to oversell this. This is only 500 meters of Hyperloop infrastructure, but we can use that 500 meters to demonstrate the technology and demonstrate it works. It also happens to be the world's 4th largest vacuum chamber. We didn't know we were getting that, but we did, just as a side effect. So, at DevLoop, which has been entirely private sector funded, this is the only place on Earth where you can now demonstrate all the bits that you need to make a Hyperloop work. And those bits, in schematic overview, are as follows. So first of all, there's the tube. We've started with a steel tube, but one of the things we think there's a great potential to do in Europe is advance materials and precision manufacturing, come up with new materials that are stronger and lighter than steel. Then there's a pod. And that's the name we use for our vehicle. And the thing about our pods is they're small. It's not a train. You don't have to wait for 400 people or 1,000 people to show up. You don't need 400-meter long stations. We can do 24, 48, or 96 seats in a pod, depending on configuration. Then the big differentiator. We take the air out of the tube. We run at our design specification is 100 pascals. That is 1,000 times lower than normal atmospheric pressure, which basically means we've completely eliminated aerodynamic drag. It's equivalent to an aircraft operating at 200,000 feet, not 30,000 feet. Then we use a linear motor to propel the vehicle. We use magnetic levitation instead of wheels, so we're overcoming friction, and a control system. So none of this existed in Hyperloop form in 2013. We formed the company in 2014, and since then, we've built it. We've built every one of these systems and demonstrated their integration into a full functional, full-scale mode of transport. So I'm going to play you a little video now which brings together some of our testing at the DevLoop site in Nevada. What you'll see first is testing of the chassis of the vehicle, of the pod, without the shell on it. And that's to give you a clearer overview of what the machinery on the pod looks like. And if you look to the right-hand side of the screen when we're going really fast, you can see the magnetic levitation happening. So, here we go.
All parties ready for test? Firing 5, 4, 3, 2, 1. Fire.
So there you have it, world's first functional Hyperloop prototype. We're very proud of it. We know what we've achieved, which is the fundamental proof of technology. We know that the difficult bit is ahead, which is proof of operations. And by proof of operations, this is where you get the safety case. This is where you get regulatory approval. And this, we believe, is where the European Union is the best place on earth to do the next stage of our technical development. So, what we have to do is go from one tube with one pod to multiple tubes with multiple pods operating at speed, switching, dynamic real-time separation, stations, operations, all of the stuff that you need to demonstrate to get regulatory approval. So, we'll generally specify this 15-kilometer piece of infrastructure for only 150 meters a second, which is only 540 kmh. But we will specify one section of it, shown in red, for 300 meters a second, or over 1,000 kmh. You see the point by the switch where the lines do that in red. In about 2019, 2020, somewhere in Europe, that will be the fastest place on the planet. So, what are we bringing to the Proof of Ops facility? It's an innovation lab. This is where we turn our technology into a human usable transport system. It's the approvals lab where we get regulatory approval. It's how we demonstrate that we can transform existing transport systems, and it's where we demonstrate how we connect places together. Why do we want to do this in Europe? Because we think European Union is already the best in the world at these kind of things, aligning transport policies with strategic economic development. Transport regulation and EU approvals tend to be internationally portable. So we know, for instance, that the Canadians or the Australians would accept all or part of a European Union regulatory structure. The Proof of Ops facility is where we optimize and achieve approval for the facility. And why would a host location in the European Union do this? Clearly for the economic benefit. About 400 direct jobs around this, a major catalyst in a totally new industry at the cutting edge of transport technology, digital and innovative. And of course, it produces ultimately exportable expertise for Europe's regulators and Europe's businesses. We think that this is a once-in-100-year opportunity to define the standards for a new mode of transport. This is that thing that has proved so difficult in European harmonization to date, which is overcoming legacy systems. Here we don't have a French legacy and a German legacy that won't talk to each other. This is a new mode of transport, a blank sheet of paper. And just at this point, I want to name check a few places. We've been delighted with the incredibly joined up response from the innovation and economic development agencies of Finland and the Netherlands. We've been delighted that our hosts here in Estonia sent their Prime Minister to our office in Los Angeles and signed a letter of intent. And we look forward to working with Estonia together with Finland to look at what the Baltics would look like if we hyperconnect them. And I'd like also to pay tribute to DG Move. We thought when we first engaged with the European Union institutions, the response would be, you're not a train, you're not a plane, we don't know how to regulate you, please go away. But the answer was, you're not a train, you're not a plane, which means there is no reason why you can't build a proving facility in Europe and then work with the regulators to develop a new regulatory framework. We found that refreshing, and we're now deep into conversation with the institutions. So, moving on. That tests our technology and it demonstrates it as a functional transport system. What are we trying to demonstrate? What's the output? The output, to make it really plain, is really, really fast transport. 300 meters a second, 1,080 kilometers an hour. But it's not just the speed that's important. Governments don't buy transport because it's fast. Governments buy transport because it delivers economic benefit. And to deliver that benefit, we need to deliver a transformational network. So I'll just whip you very quickly through what Hyperloop looks like in a typical deployment. So if you start with a transport corridor, let's say you've got an A and a B. Everybody thinks, okay, it's about connecting A and B. And let's say that A and the B are 300 kilometers apart. That is precisely London to Manchester, where I come from. That is precisely the distance that you would normally use a TGV or a Shinkansen or an ICE. And over that 300 kilometers, this is what Hyperloop does in comparison to other modes of transport. In scale time, we completely fry the distance. 18 minutes between A and B. High-speed rail will take an hour and 10. A Pendolino on a good railway will take 2 hours and 10 minutes. And of course, if you are stupid enough to try to drive between two major European cities, your average speed will be 70 km/h and it will take you 4 to 5 hours. So that's speed. Everybody gets speed, that's what Hyperloop does. But it's not just about speed. Because if you've got A and B, you've also usually got a much more complex geography along the corridor. You may need to connect ports with inland distribution centres. You may need to connect airports. And you may have new cities you need to develop if your core cities are overheating. So in schematic terms, that's what we do. We link everything to everywhere else. And this is the bit that gets me out of bed in the morning. This is the bit that is really most exciting, is we've taken the principles of internet packet switching and applied it to transport. Keep your eye on the screen. This is what happens. Every journey from every origin to every destination is non-stop. You don't get trains getting in the way of each other. Pods branch off at speed and join back in again. So what we're offering is the speed of aviation. But by bringing pods together in stream, we're offering the capacity of a train. But then by diverging in stream, we're offering the convenience of a metro. So aviation, train, metro, 3 jobs, 1 infrastructure. Genuinely transformational. So, on a European scale, not this week, not this month, but looking ahead, what could it look like? So, people have mentioned Rail Baltica. We don't want to compete with Rail Baltica. It's a brilliant railway. It's great at heavy haul freight, but it's 9 hours. We give you Berlin to the Baltics in 90 minutes. We've already published the business case for Stockholm to Helsinki. A member of the Swedish Parliament put it brilliantly to me. She said it's not about Sweden and Finland anymore. With a 28-minute journey time, it's Stocksinki. Then, of course, there's a Helsinki to Tallinn tunnel, a great European Union mega project. Because we have no air in the tubes, our tubes are massively smaller than rail. So if the rail estimate for a tunnel is 15 billion, we're confident we can do it for 8 billion. If a rail train takes 25 to 40 minutes, we're confident we can do it in 6. So you haven't got twin cities, Helsinki and Tallinn, you've got one city. Doesn't matter where you live and where you work. Then there's the big one, which is connecting Europe's gateway at Schiphol, Rotterdam, to the heartlands. Adding then a most interesting proposition, this came to us from Swiss Railways. They said, we need to get from Germany to Italy, and we have to take a 200-year view of what goes into our tunnels. So we need to talk to the next 100 years of transport, and then linking it all together. None of the dots on that map are more than 90 minutes apart. Amsterdam to Copenhagen in less than an hour. This is radical transformation. And here we are in the Baltics. And what you can see there is effectively a circle line around the Baltics. This is, for us, a sort of hyper-Hansa. This is connecting places together to improve their productivity and transform the way they work. So, I'll conclude with, what's the scale of the opportunity? And sometimes you can only see the present if you go back to the past. So cast your mind back to 1829. Imagine, as a country or as an individual, you've invested in that. It doesn't look much, but this is Genesis. This is the beginning of the Industrial Revolution at a power level, powered by coal, running on steel, with the transport capacity to move millions of tons of food, enabling mass urbanization. But imagine if your investment in the innovation of the time didn't just buy you a steam locomotive, or even a share in the factory that made the locomotive. Imagine if you, as a country, or as a block of countries, could invest in the global transformation that followed. And the scale of that transformation is that. That, ladies and gentlemen, is the Industrial Revolution. It's 2017, the Hyperloop revolution has begun, and I'd like to welcome you all on board. So thank you. Let's make it happen.
So thank you, Mr. James. Very exciting, really very exciting. Colleagues, we have 22 minutes, because I know that two speakers, planes, not the Hyperloop, but planes, will leave approximately 5 o'clock or so. So I will close the possibility to register to a floor, and I will give immediately to Ms. Teadanilov possibility to rule these panel discussions. And what is your first comments? And take the floor, please. Yeah.
Thank you, Chairman. It's a great honor for me to be here today and facilitate the debate about the future of transport. We live in revolutionary times. This is the phrase that was used by Ms. Karina Delli this morning, the member of European Parliament, and I doubt that there can be better proof to this claim than the presentations that we just heard. Thank you so much. A lot has been said, and brilliantly already, so let me just limit myself to one point only, and this is the convergence of sectors and policy fields. We have seen the convergence of transport policy with energy policy and environmental policy. We take this as common knowledge that the goals of the EU transport policy involve, for example, decarbonization or energy efficiency. The next big convergence will probably be with digital policy. If the vehicles are becoming autonomous without the need for a driver at all, so what we are talking about is actually the artificial intelligence, together with all the issues that it raises, for example, the issue of liability. And if these autonomous vehicles are not only sensing each other and the other objects on the road, but they are also exchanging information, exchanging data, then we are talking about Internet of Things, together with all the implications, for example, the risk of cyber interference. It seems to me that given the excellent interconnections between transport, environmental and energy policies, we now have to take the next step and integrate the digital policies as well. With that in mind, I'm eager to hear the intervention from the audience and the panelists. So let's open the debate. And I'm glad to see there are quite many delegates who have registered for comments. And the first one goes to Ms. Kafantari from Greece.
Dear colleagues, good afternoon. Cooperative and Intelligent Transport System, ITS, apply to road, rail, marine and air transport systems. Their aim is to improve transportation safety and environmental quality by providing real-time information to system operators and users. The aim of developing ITS is to achieve reduction of energy consumption and environmental impacts. ITS is a combination of information communication technologies which is implemented in the transport sector can lead to more efficient, safer and more economical movement of people, vehicles. The alliance of telematics, information, technology and telecommunications allows the continuous exchange of information in real time and applies to all transport sectors. Cooperative transport systems allow the exchange of data using wireless technologies between vehicles and road infrastructures and aim at increasing road safety, but must be proper installation of equipment in key areas and the development of intelligent mobile applications. Increasing energy efficiency is a top priority for my country, Greece. So we organize structures and actions to meet the goal. A particularly important parameter in energy production and consumption is the impact on the natural environment. ITS can contribute to reducing emissions from transport, CO2 and other greenhouse gases polluting the atmosphere. Some of the ITS systems are developed special to limit environmental impact. In addition, exceptional attention is given on systems that may relieve our city's traffic, reduce travel time, and increase travel safety. However, it is discovered on an international level that there is no consistent methodology that scientists may use to estimate the emissions of CO2 that the application of ITS technology could reduce. The value of ITS will therefore also be judged by their ability to reduce carbon emissions and fuel usage, mainly due to the reduction of traffic congestion. ITS are emerging year after year as one of the world's leading products, and their widespread use can make a decisive contribution to my country's growth and optimal use of its competitive edge. However, there is another important issue concerning sustainable transportations that must be considered. This is namely the issue of transition to a new fuel era. It is well known that to fight climate change, it is necessary to reduce CO2 emissions from transportation means. The rates of reduction specified for the transportation sector are as high as 60%, so it is highly drastic measures must be taken. It is noted that switching vehicles from fossil fuel to electrical does not provide a sustainable solution due to the fact that the electrical power is mainly, I say, produced by fossil fuels, while nuclear power does not provide a clean solution. So the solution is the renewable energy and the electricity production from renewable energy, and also the hydrogen as fuel. With the use of fuel cell motors and innovating materials for storing hydrogen, like metal organic frameworks, the future of a hydrogen-based economy looks bright and viable. Thank you.
Thank you.
Thank you for this good contribution. As the time is short, I suggest we take some more comments and then let the panelists to reflect upon them jointly. The next, Mr. Martin Kolovratnik. Yeah, please.
Thank you, I am here. Thank you very much. I would like to thank speakers for their great speeches, and I'm really excited about your topics. I was speaking with managers from Hyperloop in Czech Republic, in the city of Brno, Prague, and with our Ministry of Transportation. And special greetings for me to Alstom company, because, you know, in Czech Republic we have this special tasting circle. I saw your train in Czech Republic, also last year in Berlin, and I think this is, and this could be, the future. But my question, I have two questions, and I think these questions are to Mrs. Marcic. The first one is concerned electric cars. It also is a part of future, but these days I saw information in media about Norway, about Norwegian way. Norway put a lot amount of money to electric cars, to support people to buy them, to be cheap, these cars, to have cheap these cars. But nowadays they have a big problem. For example, in Stockholm, they have 80,000 of these cars, but only 1,300 of recharging stations. And the amount of growth of these cars is 100% per year, but only 20% is growth of these charging stations. So they have very big problem. What to do? Are you speaking on the field of European Union about the way how to help nations and states with electric cars not to have problems like this one? So this is the first question: how to support smartly. And the second question is concerned high-speed trains. I told to you and our colleagues today that in Czech Republic things are changing, and that we are strongly and quickly we want to build these high-speed tracks. But we are nervous about our money budget which we can give into transport investments. So my question is it possible or will be possible to use CEF instruments to build these high-speed tracks, or should we speak with you or with whom? Thank you.
Thank you very much for these very exact and clear questions. I saw that Ms. Bakran made notes, so I suggest we take one question more and then we give birth to panelists. And the next one is Mr. Iliciali, please.
Thank you a lot. At first, I want to comment on the previous comment. I didn't say that the Turkish airlines were the number one in Europe. I meant that the Turkish airport is going to be number one. And now I hear, of course, that a lot of all the speakers were speaking about the new technologies. And I want to make a call for the European Union. Of course, we have a lot of intelligent systems. We have a lot of works, and we have to speak to a common language to all the offices, and to create an integrated system for trains and planes and all kind of transportation. And of course, Turkey, even if Turkey is not so developed as all the technologies, new technologies were mentioned at the moment, in Istanbul we have a tunnel between between Asian and European parts in Istanbul. And we want to establish a quick train between Erzurum, between Erzurum and other places. And also I want to mention that Erzurum wanted to host Olympic Games Winter Olympic Games in several years, and what I want to emphasize is that we have to make a greater cooperation with the European Union and also with the traffic security and with the control security. And this control and traffic security would be a project which will decrease the number of accidents on the road. And I hope that all these works we can do together.
Last point raised, and indeed, of course, transport is an area where you cannot just sit within the borders of European Union and not connect with the rest of the world. And it is exactly the reason why in our TEN-T network policy we actually have also indicative extensions to the entire European neighborhood, which of course includes Turkey, and we are working together with our colleagues in the Turkish administration very much in all nodes. Let me just mention perhaps the ongoing talks on the air agreement. Now, to the very specific questions, electric cars and the, of course, issue of charging stations and vehicles. Currently in Europe, we do not have enough vehicles, but then again, how could you have more when you don't have a corresponding infrastructure? And that is exactly what we are trying to do with this upcoming action plan to induce, to stimulate the rollout of alternative infrastructure charging. And there will be, again, as I said, crucially, additional financial means for all the member states to rely upon. High-speed trains, again, I would recall what I said at the beginning of this session, innovative financial instruments. Grants will remain, however, for projects that are economically viable, there will be innovative financial instruments such as blending. Let me remind you, and I'm sure you've all been following the developments with the so-called Juncker Plan, so European Fund for Strategic Investment. EIB is investing a lot of efforts and money in these types of projects. So in other words, we simply have to adapt, have to evolve, and have to become more have to become experts in using new financial instruments. Having said that, I would also like to use this opportunity of having members, distinguished members of national parliaments. Of course, it all will depend on the future European budget. In the current circumstances, you hear calls for increased financing from Europe, increased funds. Of course, there is a debate to be had over the next year or so, and we stand ready to contribute. We will need substantial financial means to bridge all the gaps that exist in European transport infrastructure, and we therefore will be arguing with very solid arguments to increase the existing funding of Connecting Europe facility that, as I said, connects all three sectors. Thank you.
Thank you for this very comprehensive response. As the time is really short, so I suggest we move on. And the next comment goes to Mr. Rząsa from Poland.
Thank you very much. I am greatly impressed by the statements of the four panelists. Let me just add one comment. Alstom, is doing great in Poland. We greatly appreciate your presence in Poland. The students of all technical universities approach us and ask us, deputies, whether we can enable contact with the project of Mr. James. It attracts the interests of young people in Poland. I only learned about this recently. And a question to Madam Bakran Marcich. A couple of hours ago, Commissioner Bulc said that we can use blending as an innovative financing tool for the purpose of constructing the Via Carpathia road. This is a project which links 7 countries from Thessaloniki in Greece through Bulgaria, Romania, Slovakia, Hungary, Poland, of course, all the way to Lithuania. I would like to request a couple of items of advice from you. Is it possible to expect funding from the European Union? Thank you.
Thank you for the enthusiasm to the business cases presented before, and for the very specific question to Ms. Bakran as well. I suggest we take one more question and then we let the panelists to answer. So it's Ms. Arda Gergens is the next.
Thank you very much. My question is addressed to Mr. Eloranta. My experience with the industry-driven is that one tends to forget, indeed, to involve the public with the development. So one of the most debated subjects next to the loss of jobs is privacy. And very often these are ethical questions that arises. These ethical questions are then being discussed at the drawing room or at the boardroom, but the innovation will be so fast that I think that we as politicians won't be able to keep up, and we will have no time to influence that process that's being in the boardroom, but we will, however, have to pick up the pieces. So to me, it's by definition an industry-driven development that we're facing. Have you ever considered not to explain the citizens about the choices you make, but to invite them to be a part of your decision-making process? And wouldn't that be a truly innovative way to lead the digital era?
Thank you so much. So Ms. Bakran and then Mr. Eloranta, please.
Yes, thank you for the question. So I think what we have done, as most of you are aware, that when we have started our journey towards autonomous shipping, we have not done it in isolation. I would say it's the contrary. So we have been brutally open, to state what it is. We have also visualized our vision, with lots of, let's say, artist impressions and so. But I would still say that we haven't really directly engaged citizens. I had it in my presentation like a plea that we have to allow for public interaction. So we have given lots of interviews to all types of media, mass media especially, globally, like BBC and all the global media, and we do get some feedback after that. So, but I will take a note on your comment, and I think how we could further improve it. But this is probably something that, as a company, we have to balance this quite a lot, with the risk of openness, so the whole world knows what we are doing. And I still think that's a right way of going forward. So we are taking steps towards the unknown with this approach. Thank you.
Yes, thank you very much. I'll be very concrete. Of course, we do have some examples of really big infrastructure projects being built through CEF and other instruments, actually through combination of various financial sources, like Rail Baltica, which is very well known, of course, in Estonia. You have the Brenner Tunnel, you have Koper-Divača. So in other words, of course, there is a possibility. However, as I've said, it will probably in the future be a combination, especially for such huge infrastructure projects. So some parts could profit from some grants, some other parts of the project will be financed through innovative instruments. Crucially, of course, we need to have a good project submitted, and then again, I come back to my previous remarks, we need adequate budget in the EU, and when the debate starts, then we do expect from member states to really work together and to give us a substantial budget that we can then use to really connect Europe. Thank you.
Thank you. The next one is Mr. Pečkis from Poland, please.
Thank you very much. I would like to refer to the statement of Mr. Alan James. It is all correct if we generate hydrogen only from wind energy. German engineers at the most recent conference in Renewable stipulated a whole reform, a whole transformation as a crisis, because although the Germans are very intensely implementing wind energy and solar energy, then due to the fact that these sources of energy are very volatile, the Germans are still accounting for 48.2% of extracting coal in Europe. This leads to a situation where coal-fired electricity power plants receive very variable inflows of power energy. This leads to their lower effectiveness. What is the outcome of this? Germans showed that such ineffective environment protection systems lead to higher environment contamination than over the previous 10 years. Why did I decide to comment on this? Because this is often ignored when creating new solutions. The actual impact of the energy base, which in Germany is formed by brown coal, is often omitted. And let me refer to the costs of the reform which was implemented by the Germans over 11 years, starting from 2006, electricity became 47% more expensive. Now Germans are paying twice as much for electricity as the French. Per annum, the German taxpayer pays an additional 20 billion euros to ensure that this energy is clean. Thank you.
For this good contribution, we should take the last one as well, keeping that one in mind, and then give a chance for the panel to show comments. So, Mr. Kirsteins from Latvia, please.
Thank you. My question is to Mr. Nicholas Erb from Alstom, and question is about proportion between expenditure level for new technologies and traditional technologies. Yeah. We are fighting today with greenhouse effect, but from other side we know the mainly evaporation of water creates this greenhouse effect. And we try to got rare metals, produce lithium batteries. We develop mining, but its result is pollution of environment. And for example, network of hydrogen filling station, I think it's very expensive too. Some years ago, it was normal, very high prices of oil and gas, but today we know about this great shale gas or oil revolution. We can get very cheap, or United States supply us with cheap energy resources from other side. Europe has very big potential. In Poland, in Ukraine, is huge reserves of this shale oil and gas in future. Maybe we must develop more economic kind of engine, for example, no train with gas engine or some other kind of technologies. It's very good. It's clear air and environment. But how you see proportion between traditional technologies and very expensive this electric and hydrogen new technologies? Yeah. Thank you.
Thank you. So this was a direct question to Mr. Erb, please.
Okay, thank you very much for the question. It's clear that if you want such type of technologies to be deployed in a large scale, you need them to reach to be competitive from a total cost of ownership point of view. So you have to reach a solution where, okay, there is an investment cost up front, but you recover it, let's say, through the life of a product, either because the fuel cheaper, or because there are less maintenance operation, for example. So in the case at hand. So you have to work on these variables to make an attractive proposal for the let's say for our end customers. Otherwise, they will not buy it. That's very clear. That's what we're working on. As I said, right now we've built 2 prototypes. So in terms of industrialization and scale effect and so on, we are not there yet. So on the vehicle side, there is at the moment a delta, on which we aim to, let's say, reduce gradually as we produce more of these trains. On the infrastructure side, though, that's where there is, of course, an issue, because you have a choice of keeping using the same diesel infrastructure or investing in something new. So that's where we see, as in other transport modes as well, a need for some sort of support, especially for the first movers, to make sure that, let's say, the technology the deployment starts in line with our climate constraints, I would say. Thanks.
Thank you so much. Any other final comments from the panel?
So I'd like to address the comment from our Polish colleague on energy mix. Yep. Okay. Yep.
Sorry. No, we're going. Please, Alan,
yep.
Continue.
Okay. I'd like to address the comment on energy mix. It's absolutely the case that every transport system consumes energy. Energy is clearly location specific. Your electricity generation mix in one country will be different to another. So if we built Hyperloop in Switzerland, we would be absolutely zero carbon. Or if we built Hyperloop in Norway, we'd be absolutely zero carbon. Clearly, if you built a Hyperloop in Germany, given the brown coal generation mix, you have a different equation. We can't change the national electricity generation mix. That is something only policymakers can do, and within the framework of an overall European Union direction of travel, which has to be towards sustainability and lower carbon. But we can make a very significant contribution as a transport system to reducing carbon. And here's how it works. Because we are operating in an effective vacuum, we can accelerate the vehicle to its cruising speed of over 1,000 km/h. And then, because we're levitating, so no friction and no aerodynamic drag, the vehicle then cruises for the next 60 kilometers using 0 traction power. And then we just need to give it another little kick to re-accelerate it.
Thank you so much. Regretfully, I have to close down the debate now because some panelists have planes to catch. I thank you so much for this very informative and fruitful debate, and I hope we all learned a lot today. So thank you again.
Thank you. Thank you, Ms. Danilov. I will make very short because I know that speakers want to go to airport. I just want to say that 300 years ago it took weeks to travel from Tallinn to Lisbon. 30 years ago it was not possible to travel from Tallinn to Lisbon for political reasons. Now it takes only hours. Political will and innovation are both needed to improve transport connections, which in the end form the cornerstones of European integration process. New solutions will change our economy, society, and transport sector thoroughly. Our duty as legislators is to guarantee that the legislative environment is in line with the future solutions. Once more, I want to thank all the people involved here.